Welcome to Fred's Workbench, and I figure we'll start with the assembly of the circuit here. These little parallel to serial adapters, which are known as I2Cs, each one has their own individual code. And to find that code, you'll need to run a little program here, which is a IC2 scanner. I will include it on my web page. What you do is you upload it, uploading to the sketch, and I believe it's done uploading. Now we go over here to the little serial monitor, open serial monitor, and it starts scanning, and this is 0x27. So now we close that and we go over now to our program here. And we go down to here and change it to 27. Upload it to our program, or the module. And it should be uploading in a second here. We'll see the little lights flashing. Compiling sketch. Uploading, and start to upload. And with any luck, this display will light up. There we go. And the display is now lit up. But I don't have anything connected to it yet. First of all, before I do, I'm just going to explain on how we connect this. If you look here, we have ground, VCC, which is 5 volts, SDA, which goes to analog pin 4, and we have SCL, which go to analog pin 5, which is on your board here. And you have ground pins and 5-volt pins on the main board. Okay, next, if I can find, here we go, we have our little current modules. I'll just snap one off here. And these little modules, if we can get a close-up shot of this, they are only good for, come on, focus, 3 to 25 volts. They do read below 3, but I'm not too sure how accurate they are. And they go up to 25 volts. So I'll just plug one of these in here, just so I can see what I'm doing. Let me get my other glasses on. And I plug ground, and there we go. And now we should have, everything reading is 0. And for some reason I've got an extra 1 there, which kind of a, let me see, a push reset. Should get rid of that. I think it was when I plugged the module in, yeah, I had a little false reading. So, and if we look here, we have, if I can pull back enough, we have ground, AT, which is the amp, VT, which is volts, and we have the amps are connected to A0, voltage connected to A1. These are your analog ports. And then you have your in and out, and these modules are only rated up to about 3 amps of power, which is good for our project. And I don't know if let's see, I should have one of these other modules on hand if I can find it. Oh, here they are. And these are the modules that I used in my project. I removed the potentiometer and I soldered on a regular 10-turn potentiometer. But I noticed that these things can go up to 40 volts, which is way more than this can handle. So to limit this across the 2 leads of potentiometers, I put, I put a 5 and a 10K resistor, giving me about 15. And between that and the potentiometer, it stops right on the dot on 24 volts, so just a little over 24 volts, which is really good. And like I said, these things here, they do get a bit warm if you draw about a 1.5 amps, so I put a little heat sink on this. and I have a fan blowing across it to keep it cool. So this is the program. The program's running here now. So let's just see. We go back to the actual software, and I'll run through it. We have the liquid crystal I2C. I have the address included in the library. Your volt, currents, where they're connected. This is where you put your identification for the actual serial device on the back of your modules. And if we scroll down here, this turns on the LCD, backlight on. This reads the analog volt and amps. The calculation to take the value 0 to 1024, which is what it sends to the Arduino. So we have to divide that into 5, which will give us the voltage reading, the proper reading. Then we have the same thing for current. And then we do watts equals volts times currents. We have our LCD going to line, 0 cursor, I mean the character. That's telling it where to start. It prints the word voltage. Then 6 placements after line 0, it puts the voltage value. And it does it down to 0.3. And here I added a little statement. I'm not sure how to get the screen to correct itself. When it jumps up to 12, it moves over 1 placement, and when it jumps back, it leaves a phantom number. So I tell it, if the voltage is lower than 10, go to position 12 on line 0 and put a blank to blank out that phantom number at the end. And then down here at current, we have LCD cursor 0 position, line 1, which is the second line to be more accurate. Print A, which is for amps. We tell the cursor to move down to the second position, line 1, which is actually number 2. Print the current, 3 decimal places again. Then I tell it to go to position 8, line 1, put watts, and so on down. And when we get down to the 2 watts, I tell it again below 10 watts, put a blank at the end. I guess you get the general gist. And then I tell it to delay everything like for about half a second to update the screen. And that's more or less the program in a nutshell. So let me switch back to the here. So now you got a rough idea of how my project is put together. And like I said, I showed you that I mounted everything into a small module. I'll be showing you in the, I guess that'll be the next video, showing you that I mounted everything into the box here, which is already done and put together with all the plugs and what have you. I'll be covering up that, making it a little prettier with a little mesh I'm going to be putting over it. I have some here someplace from the dollar store. It's a little craft mesh. So this is the project I have so far. So I don't think I forgot much of anything. Well, I probably was going in the next video. I'll be talking about building a connection on the little Arduino I built on a perf board. This stuff here, a little project board, and I added a USB to serial adapter so I can program it. Made a little plug up so I can plug it in. And I was going to touch on this little thing here I made on this. See, this is unpluggable from here. See, this has a DTR, which is known as kind of like a reset. So when this thing receives a command from the computer, it sends a reset to the chip to tell it to reboot, and during that reboot cycle, it sends commands to it to kind of capture it for programming, and when it captures it, it will upload sketch. Problem is the DTR needs to be put through a capacitor and a resistor, a 3 volt hooked to the 3 volt rail, And some people say no, you should hook it to the 5, but I find it's more reliable on the 3. So I'll probably be doing a future project on these little devices here. And like I said, this is pretty well what I have. And so like I said, I'll be uploading this information to my website at fredworkbench.com. And if you like this video, please hit subscribe and like to further my projects, to let me know that you like them and you'd like to see more of them. And this is Fred signing off. Until next time.